My name is Manga, and as part of our group presentation, I will be focusing on DDoS attacks or distributed denial of service attacks. Distributed denial of service or DDoS attack is a malicious attempt to disrupt the normal traffic of a targeted server, a service, or a network by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. A distributed denial of service attack is a subclass of the DOS attack. However, the main difference lies on the scale of the attack, whereby a DDoS attack is implemented at a far much larger scale as compared to the basic DOS attack, hence the term distributed. A DDoS attack is carried out with a network of internet-connected machines. These networks consist of computers and other devices, such as IoT or the Internet of Things, devices which have been infected by malware. And it is this malware that allows the attacker to remotely control these infected devices or nodes. These individual devices are referred to as bots, and a group of these infected bots is called a botnet. When a victim server or a network is targeted by the botnet, each bot sends requests to the target's IP address, potentially causing the server or network to become overwhelmed, resulting in a denial of service to normal traffic. Therefore, by this definition, we can see that the main objective of a DDoS attack is not to gain sensitive or privileged information, but just to deny legitimate requests from legitimate users. How to identify a DDoS attack? The most obvious symptom of a DDoS attack is a site or a service suddenly becoming slow or unavailable. However, there is an exception to this rule, since there can be a legitimate rise in requests from users on certain days or certain periods. Therefore, the use of traffic analytic tools can help narrow down to spot or detect a DDoS attack. Some of these signs include suspicious amounts of traffic originating from a single IP address or a range of IP addresses. A flood of traffic from users who share a single behavioral profile, such as a device type, geolocation, or a web browser version. An unexpected surge in requests from a single page or endpoint. Odd traffic patterns, such as a spike at odd hours of the day, a pattern that appears to be unnatural. For example, a spike after every 10 minutes. So, in terms of the behavioral profile, an attacker can create a botnet targeting a specific web browser version or a specific operating system that has got a known weakness or vulnerability. So a botnet usually consists or comprises of a specific device or a specific operating system or a specific web browser version, because it is those vulnerabilities contained on those devices or software that the attacker takes advantage of to create a botnet and infect those devices with malware. The most common types of DDoS attacks. While nearly all DDoS attacks involve overwhelming a target device or a network with traffic, attacks can be divided into three categories. An attacker may use one or more different attack vectors or cycle attack vectors in response to countermeasures taken by the target. And of these three attack types, we have the application layer attacks, protocol attacks, and volumetric attacks. Application layer attacks, sometimes these are referred to as layer 7 DDoS attacks from the OSI model, which is the application layer, which is the layer 7. So targets the layer where web pages are generated on the server and delivered in response to HTTP requests. Layer 7 attacks or application layer attacks are difficult to defend against, since it can be hard to differentiate malicious traffic from legitimate traffic. An HTTP flood is an example of an application layer attack which uses a large number of HTTP requests to flood a server, resulting in a denial of service. So this is an example of an application layer attack where we see an attacker taking advantage of his created botnet and then sends a lot of requests to a targeted victim. So this targeted victim will in the end fail to service all those HTTP requests, thereby that particular web service becoming unavailable to other legitimate requests or users. In protocol attacks, a protocol attack, also known as state exhaustion attack, causes a service disruption by over-consuming server resources and the resources of a network equipment like firewalls and load balancers. Protocol attacks utilizes weakness in layer 3 and layer 4 of the OSI stack, which is the network layer and the protocol layer. SYN flood attacks is a typical example of protocol attacks, as this attack exploits the TCP handshake by sending a target a large number of TCP synchronization packets with a spoofed source IP address. The target machine responds to each connection request and then waits for the final step in the handshake, which never occurs, thereby exhausting the target's resources in the process. This is again a typical representation of a protocol attack utilizing the SYN packets. So to initiate a connection, a user or a device sends a synchronization packet to a target. Then in a normal scenario, the target responds with a synchronization acknowledgement packet. Then the initiator completes the session by sending a SYN acknowledgement packet back to the target. Thereby, now in this type of an attack, a bot sends a spoofed SYN packet to a target. Then the target sends a synchronization acknowledgement, then waits now for an acknowledgement, a final acknowledgement from the attacking bot to complete that session. But then now the bot never sends the final acknowledgement to the target. So it's creating half-open sessions. So a botnet now will send dozens, thousands, or millions of these half-ended TCP requests, thereby rendering this target inaccessible because it keeps responding to those synchronization packets, but never receiving a final acknowledgement to initiate to complete that session. Volumetric attacks. This category of attacks attempts to create congestion by consuming all available bandwidth between a target and the larger internet. Larger amounts of data are sent to a target by using a form of amplification or another means of creating massive traffic, such as requests from a botnet. DNS amplification is a typical example of volumetric attacks, which makes use of sending requests to an open DNS server with a spoofed IP address, which is the address of the victim. Then the target IP address then received a response from the DNS server for a request that it never initiated in the first place. So this is a graphical representation of how an amplification attack works. So in this case, we see the attacker using a bot or a botnet, right, spoofing the IP address of the target, which is the target victim here. So what happens is the attacker sends a request to these DNS servers or resolvers, right, using the IP address of this target as a source address. Then by nature, the DNS server sends a response or a reply to that initial request. But in this case now, the reply is sent to the target victim because it had its IP address spoofed. So this target victim is now overwhelmed by unnecessary replies to a request that it did not initiate in the first place, thereby rendering its services unavailable on or slow because it uses resources receiving reply and processing replies to unnecessary responses from the DNS resolvers. Mitigating DDoS attacks. The key concern in mitigating a DDoS attack is differentiating between attack traffic and normal legitimate traffic. So to do this, we can make use of web application firewalls. A web application firewall is a tool that can assist in mitigating a layer 7 or application layer DDoS attacks by filtering requests based on a series of rules that can be used to identify DDoS attacks. Right. So a web application firewall can function as a reverse proxy, thereby analyzing all the traffic that is intended for a destination service. Anycast network diffusion is also another approach to mitigating DDoS attacks. This approach scatters the attack traffic across a network of distributed servers to the point where the traffic is absorbed by the network. So in this case, we can make use of many servers that are servicing the same requests. So instead of having one server for a particular service, we can have multiple servers all offering the same service. Then we can have a request routed in a round-robin fashion, thereby being able to handle that request from multiple nodes or multiple networks. Then rate limiting is also another approach that can be used. So in rate limiting, the number of requests a server will accept over a certain time or a window is also another way of mitigating a denial of service attacks. So in rate limiting, what we do is we specify how much requests a given system or node can accept. So even though there can be a spike in traffic, if we set our rate limiting, for argument's sake, let's say 100, and the requests increase to 200, it means that server will ignore all the other requests, thereby no denial of service will happen in that case. Black hole routing is another method. If an internet service provider detects that a DDoS attack is taking place, then the ISP may send all the traffic into a black hole as a defense. Thereby, no traffic will be routed to the endpoints, but will be routed into a null network whereby it accesses nothing. We have come to the end of our presentation. Thank you.